Hello Year 5 and welcome back to Year 5 Science. This first lesson of the week is going to be all about gravity. What you need to do is to get yourself a new piece of paper, write down the title Gravity and today's date. I suggest you pause this video while you do so. Now, like all new topics in science, it's always good to focus on the history of how this discovery came about. And of course, we are talking about the man called Sir Isaac Newton, the man who was behind it all. Now, depending on which calendar you use, Julian or Gregorian, Sir Isaac Newton was born in 1642 or 1643 and wasn't expected to survive, but he did, and eventually went on to be one of the greatest scientists ever known. He not only discovered gravity, but also laws of motion and the light spectrum, something that we'll later go on to look at in future lessons. He was also an MP and Master of the Royal Mint, as well as President of the Royal Society. He died in 1727 and was buried in Westminster Abbey alongside Henry VII, Elizabeth I, Charles Dickens, and also the famous Charles Darwin. Did you know that the Royal Society is actually the oldest scientific institution in the world, and many key discoveries have been made there? Now, as some of you may already know, Sir Isaac Newton's eureka moment involved an apple and a tree. And legend has it that Newton was actually hit on the head with an apple, and that is how he discovered gravity. However, this isn't quite true. Now, instead, he did see an apple fall from a tree, but rather than hitting him on the head, it just got him thinking, and that's how he worked out that gravity must exist. Now, another interesting fact about gravity and newtons is the weight of 1 Newton is approximately the same as 1 apple. Now be careful, because an apple is going to fall across your screen very shortly. So what actually is gravity? Well, gravity is a force. It's an invisible force that pulls everything towards the centre of the Earth. It feels like it's pulling down, but that's because wherever you are on the Earth, it is pulling you down towards the centre of the Earth. Your feet are still on the ground in Australia, and because of gravity, down feels the same wherever you are on Earth. Now, gravity is measured in meters per second squared, or as you can see in brackets, m-s to the power of 2. Now, those words that are written in red, I would like you to write down as notes on that piece of paper that I asked you to get at the beginning of the lesson. So underneath where you've written the title and the date, I would like you to write down the 2 sentences that you see in red. So what is the Earth's gravity? Well, the Earth's gravity is 9.8 meters per second squared. But you'll commonly maybe see this rounded up to just 10 to make it easier for calculations. Now, I suggest what you do is you pause the video to make sure you've got some time to make sure those 2 sentences that are written in red are written down in your notes. Now that you've managed to write down those notes, I want us to move on and think about weight and mass. So what is mass? Well, mass is a measure of how much matter or stuff is in an object. Small objects may contain a lot of matter, like a metal ball. Larger objects may contain very little matter, like a polystyrene block. So that's mass. So what is weight? Well, weight is the mass of an object affected by how strong the gravity is on that object. So, weight is also a force. Weight is the force of a mass pushing down, because of gravity, on the surface on which it is standing. And weight is measured in newtons. Now this may seem a little bit confusing, but bear with us, and towards the end of the lesson it will all make a little bit more sense. Okay, so just think of it as mass is how much matter or stuff is in an object, and weight is the mass of that object affected by the force of gravity. So again, what I would like you to do is pause the video where we are now and note down all the sentences that are written in red. Once you are done, you can click play and continue with the lesson. So, everything has gravity. And when I mean everything, I mean every object has gravity. If it is made up of matter, it creates gravity, an invisible force that pulls things towards its centre. Now, the bigger the object, the bigger the gravity. So, for instance, the sun is huge, so its gravity is strong enough that it keeps all the planets in our solar system orbiting it. Now, the Earth's moon has its own gravity, but it's smaller than that of the Earth. So the Earth's gravity, being stronger, keeps the moon in orbit around the Earth. What exactly is the sun's gravity? Well, the sun's gravity is 274 meters per second squared, compared to that of the Earth, which is only 10. Before we move on, I just wanted to make a point about saying that everything has gravity. In principle, if you have two objects, for instance your water bottle and a Pritt stick, if you put them on a table 30 centimeters apart, if you left them for enough time, eventually the Pritt stick would move towards the bottle of water, because the bottle of water creates its own gravity, and that is stronger than the gravity of that of the Pritt stick. So eventually the Pritt stick would move towards the water bottle. However, this would take so long that unfortunately no one would be around to ever witness what has actually occurred. Okay, moving on. We know that the Earth's gravity is stronger than the Moon's gravity because the Earth is bigger than the Moon. The Moon's gravity is 1/6 of the Earth's gravity, so an object with the same mass will actually weigh differently on Earth than it does on the Moon. So an astronaut that weighs 120 kilos on Earth, even though the astronaut doesn't change size or mass, their weight on the Moon would be just 20 kilos. Okay, 6 times less. So what is the Moon's gravity? Well, the Moon's gravity is 1.6 meters per second squared. So if we then take that knowledge and move forward, when we jump, we forget that it's gravity that makes us fall back down to the ground. On Earth, we are used to knowing what a jump feels like. But on the Moon, the pull of gravity is much weaker, so we fall back down to the ground much slower, leading to the floating effect that you may have seen astronauts experiencing on the Moon. However, if you flip this idea on its head, on a planet that has twice as much gravity as Earth, you would find it really hard to jump at all. Not only that, but your legs would have to be much stronger just to hold you up and stop you collapsing. So what about Jupiter's gravity? Well, on Earth we said it's 10. On Jupiter it's 24.8, so it's 2.5 times stronger nearly than it is on Earth. So you may have heard of something called zero gravity. Well, actually there is no such thing. Even when astronauts are in space, they are still being affected by gravity from the sun and planets. There is a tiny bit of gravity everywhere in space. When things including astronauts are far enough away from a planet, they are only affected a tiny little bit by gravity from that planet. This means that they float around and are not really dragged back to the surface of the planet, as the gravity isn't actually strong enough from that distance. Which is why zero gravity is not quite the correct explanation for this. It is actually something called microgravity, meaning that there is a tiny bit, but not none at all. So why do astronauts float in orbit inside the space station? Well, astronauts are actually experiencing something called weightlessness, which is due to the speed by which they are travelling. It's more like being in free fall. So for instance, that moment when you reach the top of a fairground ride or the top of your trampoline bounce before you start coming down, well, that's a moment of weightlessness. Now, we have a little bit of a home experiment or task to complete before the end of this lesson. So well done for listening and watching this far. This is now your task, and your task is as follows. Number 1, you're going to find out your mass. So go to your bathroom at home and find your bathroom scales. If they're not in your bathroom, ask your parents if they've got a set of scales that you can measure your mass on. Make sure they are measuring it in kilograms and record your mass. Once you've done that, you're going to note down, obviously, your mass on your piece of paper, and you're going to multiply your mass by 10 to give you your weight on Earth. Okay, that's going to be measured in newtons. Then you're going to try and calculate your weight on the moon. So you need to then multiply your mass by 1.6. Again, write your answer down in your notes. For example, here is myself. Mr. Isaac, which is me, has a mass of 70 kilos. Maybe a little bit more now, post-Christmas. But the last time I measured, I was 70 kilos. On Earth, my weight is 70 multiplied by 10, which gives me a weight of 700 newtons. On the moon, however, my weight is 70 multiplied by 1.6, which gives me a weight of 112 newtons. Okay, a sixth of that of what it would be on Earth. Now, I would like you to complete your own calculations, written like mine, in your notes over the next 5 minutes. Again, pause this video while you are carrying out this short home experiment. So, what have we learned? Well, what can you remember? I'd say chat with a friend, but unfortunately we can't right now, and we will chat together shortly as we meet at the end of the lesson together. However, what are the main points we've talked about? So, Sir Isaac Newton discovered gravity. There's no such thing as zero gravity, just microgravity. Every object that has a mass has gravity, and it is a force that pulls things towards its centre. The moon's gravity is a sixth of that of the Earth. Mass is measured in kilograms, gravity is measured in meters per second squared, and weight is measured in newtons. And we've also found out our own weight on Earth and also our own weight on the moon. That is the end of our lesson on gravity for today. Thank you very much for watching and listening, and I look forward to speaking to you all again for your second lesson of the week, which is going to be even more of a home experiment than the short task you did today. Thank you very much and enjoy the rest of your days. Goodbye.